Drug labels can feel pretty confusing to read. The name indicates the organic molecule that is the important ingredient in the drug. But it doesn't mean much unless you know how to read the diagram chemists use to represent molecules. Fortunately, I'm here to help you learn how to do it. Let's try and make sense of the packaging. Esto es Real Chem. Learning how to interpret line drawings in chemistry is important to using our knowledge in the real world. Line drawings are a convenient way to represent the type of information we get from Lewis structures and Vesper theory. So there is nothing here that goes beyond what we've already learned. It's just a different way of representing that same information. Line drawings make it easier to show the chemical structure of a molecule, especially for drugs and other organic molecules that have lots of atoms. Exploremos. This convention for drawing molecules, often called a line diagram, is especially useful when drawing organic molecules, which primarily contain carbon, hydrogen, oxygen, nitrogen, and halogens like fluorine. The convention assumes that the connection between two lines is a carbon. If we were to label the carbons, it will quickly start to look pretty busy. This convention also assumes that all the atoms have a formal charge of 0. This is easier to work with than it sounds, because all we need to do is count the bonds around each atom. The number of bonds is 4 for carbon, 3 for nitrogen, 2 for oxygen, and 1 for the halogens like fluorine, chlorine, bromine, and iodine. The number of lone pairs increases to ensure an octet, from 0 for carbon to 3 for the halogens. If an atom doesn't have the required number of bonds, it means there are hydrogens that are not being shown. Let's start with the carbons and add single bonds of hydrogen until each carbon has 4 bonds. This carbon shows only 1 bond, so it gets 3 hydrogens. This carbon only has 2 bonds shown, so they get 2 hydrogens each. These carbons only have 3 bonds shown, so they get 1 hydrogen each. The nitrogen atom only has 2 bonds shown instead of 3, so it gets 1 hydrogen. The oxygen has 2 bonds shown and the fluorines have 1 bond shown, so these do not get any extra hydrogens. Now let's add lone pairs. The nitrogen gets 1 lone pair. The oxygen gets 2 lone pairs. And each fluorine gets 3 lone pairs. Now that we have the structure fully shown, we can better understand the bonding patterns and some aspects of the 3-dimensional structures of the molecule. These atoms each have 4 electron domains around them, so the hybridization is called sp3. And since there are 4 bonded atoms, the geometry is tetrahedral, with an ideal bond angle of 109.5 degrees. This atom has 4 electron domains around it, so the hybridization is sp3. And since there are 3 bonded atoms, the geometry is trigonal pyramidal, with an ideal bond angle of 109.5 degrees. This atom has 4 electron domains around it, so the hybridization is sp3. And since there are 2 bonded atoms, the geometry is bent, with an ideal bond angle of 109.5 degrees. These atoms each have 3 electron domains around them, so their hybridization is sp2. And since there are 3 bonded atoms, the geometry is trigonal planar, with an ideal bond angle of 120 degrees. So next time you run into a drug label that feels a little bit confusing, take your time to decrypt what it's telling you. Make sense of the information from a chemistry point of view. It will not make you feel any better, but it might impress your friends and family. So explore, and remember to have fun. Explora y diviértete.